All right, here's some of the details that you need for writing the PostLab guide for the electric car. So there are 6 terms that we have talked about since we did this lab that apply to this situation. So the word position, origin, velocity, and speed, those 2 things are different. And then a vector quantity and a scalar quantity. So quickly, are there any questions about what is being referred to by any of these terms? Is there one that would be helpful to go over? That's the number that only describes how big a quantity is. It doesn't say which direction it is. So like when Will Quincy is speeding to Fond du Lac, he goes 85 miles per hour. Versus a vector. Vectors have 2 things. What do vectors have? Direction and magnitude. Oh yeah.
Oh yeah. Oh yeah.
Okay, direction and magnitude. Okay, so Will Quincy drives 85 miles per hour north or 85 miles per hour. Right, well, okay. Any other terms that would be helpful to review? Okay, so the data is already done. You guys have already done this. The data is your graph. You've already submitted it, or you should have already submitted this to Google Classroom. X, remember, stands for position, which is kind of confusing. X is on the y-axis. I'm sorry. That's just the way it is. All right, that's whoever decided this. The letter X stands for position. Position is the dependent variable. So position is on the y-axis. All right, so X is position, T is time. Your graph should be a position versus time graph. Okay, the next section, if you're following along on that pre-lab writing guide, this has 3 different sections. So it's the best fit section. So you have to decide which set of questions do you answer. Okay, if your graph is a line, then you're going to answer the first set, question set number 1. If it is a curve, then there are separate questions. That's question set number 2. And if the image that you're analyzing is some type of a scaled drawing, then that's the questions in set number 3. Okay, so ours obviously is this one. Yes?
Oh, that was what I was our best at home.
Jack, I can't really understand you. If you are too far from your wireless router, you can type your question, and then I can come back to it.
Yeah.
Can anybody at home understand me?
I can understand you. I can
Oh,
understand Jack.
okay, you can understand me. Jack, this is your problem, not my problem. Okay, sorry, Jack, you gotta type your reply. Okay. Once you have decided that you have a line, which you do, and many of you have multiple lines, you're only going to analyze one line, okay? So when you do this straight line of your y versus x graph, I should say versus. Straight line y versus x graph, just pick one of the lines. Oh no. Pick one of the the lines. Okay, so we went over this yesterday. The very first thing that this question set asks you to do is include the helper box, which you should have done. So check, that's done already. The second thing it asks is to write the equation that is specific to the graph. So if we were looking at the example from the optical micrometer, this is the thing on the y-axis. So you use the symbol, the short symbol, for the y-axis, and then the slope with the units. Multiply it by whatever is on the x-axis. So in the optical micrometer, that was pages. And then you have to add or maybe subtract the y-intercept with units. Okay, so this is an example that would have been acceptable for the optical micrometer lab. For us, the symbol for position is the letter X. The symbol for time, we said this yesterday already, is a T. So instead of Y, we're using X. And instead of X, we're using T. So you're going to substitute the variable into this generic. Okay. That's the generic equation for a line. You're going to substitute your variable. The third asks you to describe the slope. It's really helpful if you use units. So for example, in the optical micrometer, you would have said the optical micrometer slope decreases by 0.74 centimeters every time one sheet is added. That would be an example of how to describe the slope using words. Okay, I still had a lot of questions about the 5% rule. So this is the little decision-making tree that you can use to help you understand whether you should apply the 5% rule or not. So you look at your graph. Logger Pro will give you some number for B. Because you don't have perfect data, you're going to have a B value. It might be super tiny. Okay, it might be 0.00456 meters or something like that. That's a really small value. What you have to decide is, should I keep this value or should I ignore it? So you do this little calculation. You take your B value, divide it by the highest Y value, and then you're multiplying it by 100 because it's a percent. If that value is smaller than 5%, 5% in high school physics is kind of that's the goal. If you can get something within 5%, you're doing it right. Okay, so if that number is smaller than 5%, we're going to say that this relationship is actually a direct relationship. The existence of the intercept on your graph probably was a result of an error in your measurement. But if this quantity is larger than 5%, we're going to say that intercept actually should exist. So if you ignore that intercept, that means you have a direct relationship, or you should have a direct relationship. If you keep that intercept, that's a different kind of relationship. That's called a linear relationship. So this is what the 5% rule helps us decide. Do we have a direct relationship or do we have a linear relationship? Okay, after the 5% rule, then it asks you to describe what does the vertical intercept mean in real life. So you're going to use words. For example, on the optical micrometer, you could say, when there were 0 pieces of paper, the reading on the micrometer was 11.4 centimeters. That's a reasonable use of words to answer this question. Oops. You don't have to determine the value of the y-intercept because it's already given in the equation. The next two questions relate to the horizontal intercept. So it says, determine the value of the horizontal intercept by either inspection or calculation. So what that means is inspection just means look at the graph and estimate where does this line cross the axis. You might be able to see it on your graph. However, not every graph shows this very clearly. If you can't see where the line would cross the intercept, you're going to calculate it. So you have the equation for your line, and you need to solve for what is the value of x when y equals 0. Okay, so those are the two possible ways for you to get the value of the horizontal intercept. But then when you describe what that physically means in real life, you're going to follow kind of the same thing you did for the vertical intercept. It's really helpful to use units of both variables. So you would say something about like when the position was 0, the time would have been whatever. That might mean you have a negative number. Can you have negative time? What does that mean, though, for the experimental setup that you had?
You need to flip it.
Say it, Jack Norris.
You need to flip it around or change it.
You don't need to. You can say something about this motion. So, like, if your graph looks like this, which direction is the car moving? Away from the detector, right? So if you use the motion detector, this one is moving away. What does this mean? So let's say like this value is negative 2.6 seconds.
It just took 2.65 seconds.
Well, Quincy?
Oh, it's just before you started recording the time.
Yeah, all this means is that it would have been at the origin 2.6 seconds before the timer started. Okay, so there's no such thing as negative time, but you can say, like, relative to when the clock reading began, where would it have been? So for the optical micrometer, we had an actual value, but for this one, there's no true value of the velocity for your graph. Last section asks you to come up with a hypothesis. All right, so it basically is a fill-in-the-blank statement. All right, Mr. Vote's packet says if, like the word if here, and you can use if you want. I think for me, it makes more sense if you use the phrase as long as, and then the thing that you don't have any control over. So like what's one of the things that can affect the speed or velocity of this vehicle that's kind of out of your control? The battery. Okay, so you can say something about the battery in this section. That would be fine. Okay? And then the rest of it is I think that it is pretty self-explanatory based on the rest of the lab report we've just talked about. Then the graph of the position versus the time is depending on what you did with the intercept. Did you keep it or did you get rid of it? Jack?
This is just like a question over. Are we answering like the same exact questions as the last time?
Yeah. This is the PostLab format.
So we answer like the same exact. Like,
Yes, you answer it the same way. It's specific to your graph, so like the data is always
But all
different.
like the questions and everything.
Yes. Okay, so then you relate the graph and the equation. Sometimes those things are related. Okay, so the equation relating the dependent variable to the independent variable is, now if this was like a curve, you could say it's a quadratic equation, or you can say it's either linear or a direct relationship, or it gives examples in the packet. Okay, yes.
So I was taking notes on like this PowerPoint thing, like you went like really fast like you said, Where can we find the recording thing?
I'm about to post it to Google Classroom.
Perfect. And then when you said we're writing this on Monday, or is it due on Monday?
We're writing it in class on Monday.
Oh, gotcha. So then we don't even need, okay, never mind. Perfect, thank you.
Yep. Anything else about the PostLab guide? Okay.